minus 4g sine 30 equals 4a. At this stage, I'm going to start calculating values. So 0.6g cos 30, so 0.6 times by 9.8 times by cos 30, making sure that my calculator is in degrees mode. 5.092, and I'm going to keep that value in my calculator so I can use it later on. So I'm going to store that. Then I've got 4 times 9.8 times sine 30, which is 19.6. So overall what I have is t minus 24.692, etc. equals 4a. I'm going to draw a big blue box around that because that is my equation 1 that I'm going to use to solve simultaneously later on. So that's for particle A. I'm now going to do the same thing for particle B. You'll be pleased to know this is a lot more straightforward. Right, so for particle B, again, using resultant force equals mass times acceleration. Resolving in the direction of motion, which is downwards, that means that for B a downward force is positive and an upward force is negative. So I have 7g acting down, T acting up, so that is the only two forces. So I have 7g minus T equals 7a, which is the mass of particle B. So 7g, 7 times 9.8 is 68.6 minus T equals 7a, and I'll draw a big blue box around that because that is my second equation. I now have two equations for the system which I'm going to solve simultaneously, and that will give me T and A. So here we go. Right. So equation number 1 then. T minus 24.692. Remember, I've got that value stored in my calculator for when I need it. And then 68.6 minus T equals 7a. What I'm going to do now is I'm going to add those two values. So by adding those two equations, the t's will cancel out because you've got plus t minus t, and I've got 43.9077 is going to equal 11a, which dividing through by 11, a is 3.9916. Which means that I can state that A is 3.99 meters per second to three significant figures. And if I substitute that value into either of the equations, so if I multiply it by 7 and subtract it from 68.6, I get my T to be 40.658, so my tension is 40.7 newtons to 3 significant figures. So let's just go back, check that I've fully answered the question. Find the initial acceleration of A, yes, I've done that. Find the tension in the string, yes, I've done that. And I did it all together. The way that this is marked as a single question, and it doesn't actually matter which way round you find acceleration or tension, because you're solving simultaneous equations. It doesn't matter which of the two variables you find first. So, quick review then. We began by drawing a really big, clear, good diagram. We labelled on it all the forces that were acting on the system, taking particular care for the ones that we had to resolve here, remembering that everyone always forgets the weight component down the slope. We resolved perpendicular to the plane to find the normal reaction force, because that allowed us to find the value of friction. And once we had the value of friction, we were able to write an equation of motion for A, resolving parallel to the plane. Once we'd done that, we did an equation of motion for B. We then solved those two equations simultaneously, and that gave us our value of A and our value of T. Thank you very much.